Good afternoon to all of you. Myself, Dr. Satyajit Patel from SBNIT Surat. So we have developed some angular-shaped lightweight aggregate from fly ash. So that I will discuss. So this is the introduction part that in the construction industry we need huge quantity of coarse aggregates. That around 232 million tons of fly ash is being generated in India per year, and aggregate demand is around 4,500 million tons per year. And 1 cubic meter of concrete needs 1.7 ton of stone aggregates, and 1 kilometer of road needs 8,500 ton of coarse aggregates in base and subbase layers. So these are the few alternative aggregates for which technology is available, like steel slag, sintered fly ash aggregate, copper slag, glass aggregate, all such these things. So sintered aggregate is a round shape aggregate that I will discuss. So these are various methods, so I should skip this introduction part. That pelletization method, compaction method, extrusion techniques to produce lightweight aggregate. This is the method for hardening or curing of these aggregates: cold bonding, hydrothermal, sintering, and complete melting. So in case of sintering, the sintered fly ash aggregate is available, but its temperature required is quite high, so that's why its cost is quite high, sintered aggregate. We have used the cold bonding and hydrothermal. There are few various papers available on sintered fly ash aggregate. So the drawback of the existing technology here: higher energy consumption and complicated process. Process are costly and time consuming, and sintered aggregate or pelletization method gives the round shape aggregate which has negligible interlocking properties, requires high temperature which increase the cost, production cost. So in our case, we have studied the effect of curing method, curing temperature, then optimum mix proportions, and then finally we have developed the optimum mix to produce the aggregate, and we have determined all the required physical and mechanical properties of these aggregates. So these are the few photographs of this angular shape aggregate. One patent is already granted on March 21st, 2021. So this is a simple mechanism: fly ash, binder, water, mixing, compaction with high static press machine, then curing, then finally crushing to angular shape. So this is the laboratory scale instruments available with us. That mixing, then block making machine prepare the block. So each block is pressed with 50-ton load. Then either curing in autoclave or curing in water bath. If it is a high calcium fly ash, we need water bath only. For low calcium fly ash, we need autoclave. And finally the block will become hardened, and its compressive strength of the block is about 35 to 40 MPa. And for normal brick, the strength is around 7 to 10 MPa only. So around 5 times of the normal brick. So finally we have crushed the block to get the angular shape aggregate. The photographs of the aggregate, different shape and size will get after crushing the blocks. And at present, the sintered fly ash aggregate plants are available at few locations in India. And this is a comparison of sintered fly ash aggregate with our proposed aggregate. In sintering process, it is tedious. Temperature is 900 to 1200 degrees centigrade. In our case, temperature required is only 70 to 80 degrees centigrade for high calcium fly ash, and in autoclave curing around 150 to 180 degrees centigrade for low calcium fly ash. In sintered round shape, in our case it is angular shape for better interlocking. And see the cost. In case of sintered aggregate, the cost goes to around 1800 to 1900 per meter cube. In our case, the high calcium fly ash, the cost is around 460 per meter cube. For low calcium fly ash, it will be around 900 per meter cube. So these are all the required mechanical properties of the aggregate. And also the aggregate has been tested at NCCBM laboratory Ballabgarh. And This aggregate fulfill all the requirement of IS code and more for use in the road aggregate and use in the concrete aggregate. That only the water absorption is quite high, but even the water absorption is more in the wet condition or saturated condition also, the strength is giving satisfactory result. So these are the leaching tests also we have done on the aggregate, and all the leaching of heavy metals are within the permissible limits. These are the concrete specimens we have prepared of M25 grade concrete we have casted in the laboratory using this flash aggregate. The cube testing, then split tensile strength test, beam test or to get the flexural strength of the concrete, the pull-out test or the bonding of reinforcement bar with the concrete. And this is the test result and comparison of the lightweight concrete with natural concrete. We have used the same water cement ratio 0.41, cement is 330, sand quantity same 712 kg per meter cube. And you can see the difference in the aggregate quantity. In case of lightweight concrete, we need 770 kg aggregate. In case of natural concrete, it is 1301. Density of concrete around 2000. It gives you lightweight concrete. Slump 70 we have got, and you can see the 28-day compressive strength, which is similar to that of natural concrete. And also it fulfills the IS code requirement, the split tensile strength, flexural strength, bond strength. All the parameters it satisfactorily fulfill the IS code requirement, and also comparable to the natural concrete. The financial analysis part for setup of a pilot plant for manufacturing these aggregates. The simple that batching plant is required to mix the fly ash and with the binders. Then your brick making machine or block making machine, and your either autoclave for low calcium fly ash and water bath for high calcium fly ash. The crusher or same stone crusher can be used to crush the blocks. So for high calcium fly ash of capacity 40 ton or 42.7 meter cube per day, it needs around 2.2 crore to set up a pilot plant with this capacity. And the cost is coming, this is 460 rupees per meter cube. All the cost has been taken into account: raw material, power authority, manpower, depreciation and total maintenance. Only land cost is not included here, land cost. This is similar for low calcium fly ash. For same capacity, we need 4.68 crore for low calcium fly ash, because here autoclave is required, so that cost is quite significant, autoclaving cost. And in this case, the cost is coming 946 rupees per meter cube. Here, cost of steam is not included. The steam from the power plant, waste steam can be utilized in the boiler, in the autoclave to give the curing. And this is the rate as per CPWD. And the cost of coarse aggregate is around 1400 rupees to 1300 rupees. So the flash aggregate can be cost effective and also good enough to take all the load, or it gives all the required, fulfill all the requirement of the IS code and more. So these are the conclusions, that this aggregate fulfill all the requirement and it can be a cost effective solution for disposal of fly ash. Even if we use all the fly ash to produce this aggregate, then also we cannot fulfill the demand of aggregate in the construction industry. It is quite high, the demand of coarse aggregate. In Surat city only, around 25 lakh ton of aggregate is being used every year. So the sample of this aggregate has been kept in the exhibition stall also. You can see the sample of all these coarse aggregates. So these are the few references. Thank you all.
Thank you so much, sir.